Different function. All right, so next up, we're into transformations of logarithmic functions. And so a bunch of our old values that we had before are coming back. And what I mean by that is we can have a logarithmic function in the form f of x is equal to a. That's a common one. Log base 10, or any base really, k times x minus d. So there's our k value and our d value, and plus c, which can be graphed by applying those appropriate transformations. And again, our parent function here is f of x equals log base 10x. And we'll always stay with the log of base 10 for us. There's no reason not to, really, because the process is the same. So again, if f of x is equal to log x, again, that means that it has a base of 10. And there are going to be 3 key points that we're going to use for our transformation. And the points are that we have is, I'm going to go a little backwards here, is we're going to look at -1 for y, 0, and 1. And the reason I'm looking at those values in terms of the y's is because, again, the logarithmic function is the inverse of the exponential function, which means you flip the x's and the y's. So I'm going with a few negative values, a few positive values. Our corresponding x values would be 1/10, 1, and 10. But again, if you recall with the, and this does make sense, if you recall with the log function, essentially we're just taking the number 10 and what exponent on it would give you your x value. So 10 to the power of 1 would give you 10. 10 to the power of 0 would give you 1. And 10 to the power of -1 would give you 1/10. Now, just quickly graphing this information on our graph, this is what our log function original looks like. 1/10, -1, so that's down in here somewhere. X value of 1, 0, and x value of 10, 1. And that is something that we did sketch earlier on, and you could keep going. That's essentially what our logarithmic function looks like, just like that, our original. All right, but we're into transformations. So we'll go a couple of ways. First off, in words, describe the transformation that must be applied to our base graph to g of x. All right, so again, this is where it says in words, but I'm going to start off just for a reminder of going through process of spotting the a value, for instance, which is a number in front. Our k value will always be inside the brackets, inside the function, or in front of the x. In this case, it isn't, or we don't see it, so it's a 1. All right, we don't have any movement, no plus or minus inside the function, so d is 0. But our c value here is -3. Now it says in words. So in words, because our a value is 5, we have a vertical stretch by a factor of 5. And since our c value is -3, it is shifted down 3. There we go. All right, in G, or sorry, B, which is the g of x, well, I guess they're all g of x functions. We have B. Again, my a value is in front, so that is a -2. Again, no k value, no value in front of the brackets. So, well, there is a k value, it just happens to be 1. D, there is a value inside. Now, again, this is a reminder that D always looks the opposite, so it's a -5. And again, there is no number afterwards, so C is 0. Now, because A is negative, this is, first of all, reflected across the x-axis. All right, the value of A, the absolute value of A is 2, so it is, again, a vertical stretch by a factor of 2. And because our d value is -5, this has been shifted left 5. There we go. Let's see. Let's try C. Again, try to mix it up here, a bunch of different things. A values out front, but I don't see it. So again, it is just a 1. We do have a k value is equal to -4. D value inside, again, it always looks the opposite. And so that's a -1. And our C value is an 8. All right. Now, here's where things get a little different. First of all, the negative sign on the K. You know what? I'm going to do the D's and C's first. So first off, the easy part, the shifting. It is shifted left 1, up 8. There we go. That's dealing with the D and C. Now we get to the K. First off, the negative sign. So that means we have a reflection across the y-axis. Now, the k value is 4, and the k and the d inside the function will always act a little bit different. What that means is we have a horizontal compression by a factor of 1 over k, or 1 over the magnitude of k, which in this case would be 1 over 4. You got to watch out for that one. That's a little one different. All right. So that's in words. Now we're actually applying this stuff. So given the parent function, which is our base function, base log function, state the equation of the function that results from each of the following transformations. All right. So it's vertically stretched by a factor of 3, reflection across the y-axis, and shifted left. So again, before I write the equation, I'm going to write my values here. All right, so vertically stretched by a factor of 3. That's telling me A is 3. It's a reflection across the y-axis. That is secretly telling me that K is negative. And since I got no other information, it's going to be -1. And it is shifted left 5. So I got D is equal to -5. All right, so now to write the equation. And of course, whoop, can't forget it. Well, then that means no mention of C, so it's 0. All right, so to write my equation, I got y equals, A comes first, so we get the 3 times the log. I don't have to put the little 10 here because it's assumed if I don't, there is a 10 there. Any other number you got to put there. All right, K is -1. Let's have a bracket here, X. Now, D is -5, so it always looks the opposite. So because there's supposed to be a minus sign in there, so the minus sign that's supposed to be in the equation and the minus sign from the -5 connect to give me a +5. And then there's no C. There we go. There's our function. There's our transformation, I guess you should say. All right, next up, we have reflected across the x-axis. All right, so that's telling me my A value is negative, and since I don't know anything else about A, it must be just a -1. Now this one. A, horizontally stretched by a factor of 4. You invert it, and it's actually telling me my K value is 1/4. You have to invert that, just like I inverted it up here, where my K was 4. To work the opposite way, I had to do the reciprocal. Then we have shifted right 3 and up 10. All right, so again, that's just me writing out my values. That doesn't prove anything. That doesn't come up with any equation or nothing like that, but just helps me write out my equation. So now I have y equals -1, because that's my A value, log. I got a base 10 here. My K value is 1/4. Bracket. D is 3, so I'm going to have a X -3. Because again, there's supposed to be a minus sign in there. And then my C value is +10. And that goes on the outside. And there we go. So there's the equation of my transformation. All right. Now to actually do some transformations. And again, I'm going to scale up here. I'm going to use my 3 key points here for my logarithmic function to do my transformations. All right, so we get to example 3. Given the parent function, there it is. Sketch the function of the graph g of x, which is 2 log 10 x minus 2 plus 3, and state the equation of the asymptote. That's something I forgot to talk about, is that the asymptote of our original function, it has a VA at x equals 0. Something I forgot to bring up. There we go. Good timing, though. All right. State the domain and range. We're not going to do that this time out. We're not going to worry about the domain and range. So if it asks for you in your homework, don't worry about it. We're not doing it. But here's what we are going to use. Got a big chart here. And I've got my x values. I've got my y values. And then we're going to find our transformation values. Now, again, I'm using the x values of 1/10, 1, and 10. These are my original points because I'm going to get y values of -1, 0, and 1. Now, what this comes down to, or what we're going to revert back to, is we're going to end up back with our original equations, transformations equations, where we had x1, all over k, plus d. And there's our x1 values, and all these values inside our chart are going to be our x2 values, our transformation. Same thing with our y1 here. We're going to use our transformation equation of a times y1 plus c. But here's what we're going to do. Now I'm going to look up into my equation and find those a, b, and c values. All right, and so in this case, I look before the function, and a is 2. I look inside the function. It looks like our k is 1. Our d value inside the brackets, it looks like there's a minus sign in front, but there's supposed to be 1, so d is actually 2. All right, and our c value is 3. Now, what I can do here is actually simplify these equations. So I've got my different x1s I have to plug in. All right, but I'm going to plug it into x1 divided by 1. Well, that's just going to be an x1 plus d, which is plus 2. So I'm pre-simplifying these formulas so I don't have to do it over and over again when I substitute in 3 times. All right, same thing here with y. I'm going to have 2 times y1 plus c, which is 3. All right, so I'm going to start at the bottom because I got whole numbers here. So let's see here. 10 plus 2, well, that's 12. 1 plus 2 is 3. And then 1/10, which is actually 0.1 as a decimal, plus 2 would be 2.1. All right, over on the y's, same idea. It doesn't matter where I start here because I got all whole numbers, but 2 times -1, I'll do the first one. 2 times -1 is -2 plus 3. We get a 1 here. Next, y1 is 0. 2 times 0 is 0, add 3. And then our last one here where y1 is 1, 2 times 1 is 2, add 3 is 5. So these are now in green are the coordinates of our transformation. And so I'm going to sketch them in. So the first one is 2.1, 1. Put a dot there. 3, 3. 3 right, 3 up. And 12, 5. I don't know if I'm getting that one on there. 4, 5, 6, 7, 8, 9, 10, 11, 12. I guess I forgot to check my graphics out, but 12's over here. We're going up 5, which is all it can do. So my graph's going to look something like this. That's my transformation of my log function. Now, one thing before we finish is b here. State the equation of the asymptote. If the original asymptote is at x equals 0, anytime it's shifted left or right, that is going to be our new asymptote. So we will be looking at our d value for our new asymptote. And so because this graph is shifted right, so is the asymptote. And so there is a VA, vertical asymptote, at x equals 2. Again, that is determined by our d value. So I'm going to stretch it a little bit. There we go. There's our asymptote. All right, so let's try another one of those. Do a few of them here. All right, so it says, given the parent function there, we're going to sketch. Again, it's crash, domain, and range here. All right, so again, I'm going to write down my values first before I do my chart. So my A value there out front is equal to 1. All right, K value, we got one there. It is 2. My D value looks like it's going to be a -6. Okay, so that also right away, just coming off our last example, if this graph is shifted left 6, that means there's going to be a VA at x equals -6. All right, that's just so we can get that out of the way. All right, now our tables. So there we go. Again, I've got my x value, my y values. These are my originals, where I have 1/10. It's -1. I have 1, 0, 10, 1. All right, so I'm going to use my equations. Once again, I'll write those over where I have, and this is my x1 over here. So x1 divided by k. All right, plus d. I was going to short form it already. All right, same thing over here. This is my y1, so I've got y1 times a plus c. All right, so this formula here, I'm going to have, let's see, k is 2, so x1 divided by 2 minus 6. I guess I could just write that, but x1 divided by 2 minus 6. All right, over on our other side here, we have a, which is just 1 times y1. Well, that's just going to be a y1 plus c, which is nothing. Okay. Well, it looks like the y1s aren't even changing on this side. That's odd. It's just our x values. All right, so let's see here. I'll start at the bottom again, whole numbers. So 10 divided by 2 is 5 minus 6. That's a -1. 1 divided by 2 is a half minus 6. Minus 5.5. And then I get my calculator for this one. Let's see here. 1/10, which is 0.1, divided by 2. Whoops. 0.1 divided by 2. All right, it's 0.05 minus 6. I get minus 5.95. All right, so now I can graph this thing. Again, I've got my VA at x equals -6, which is right here. All right, now I just plot my points. So I have negative 5.95, -1. So that's basically right in here. I got negative 5.5, 0, right there. And then -1, -1, or -1, 1. And there again is my graph sketch of my function. All right, I'm going to do one more here, folks. Let's see here. Let's go with number 6. A little tricky here. This one's got a little trick to it here. All right, so example number 6. There's our parent function, same old. Now we're going to sketch g of x. Now here's why I say things are a little different with this one, is that it's not written properly. All right, now the key here is look at the k value. There's a multiplier in front of x. and it should be out front. So I am going to have to rewrite this function. So it's a little bit of a trick here. So g of x is equal to 3. But what I have to do here is I have to factor out this negative a half, which means I got to divide every term in this bracket by negative a half, because I'm going to factor it out, negative 1/2, because it's going to be my k value, so that I get it in the proper form. And so if I take 2 and I divide it by negative a half, I get minus 4. So there, I've rewritten this out so it's in the proper form. And now I'm going to do all the same steps, but that was just one extra step there. So you got to watch out for that. This wasn't in the right form here. And so now my a value is 3. My k value, which I can properly identify now, is negative 1/2. All right. My d value is 4. And my c value is negative 3. So we got a lot going on with this one. All right. So now, again, I'm going to draw, well, first of all, d value. My VA, if this graph is shifted right 3, well, then my VA is at x equals, or sorry, right 4, then my VA is shifted 4. So I have a VA at x equals 4. All right, so again, just got rid of the asymptote aspect of this. Now it's my chart. So I've got my x, got my y. Again, we've got our 3 values we're going to work with. We have x is 1/10, which is again 0.1, 1, 10. The corresponding y values, we get negative 1, 0, and 1. All right, and again, our equations that we're working with, there's our x1 here. X1 divided by k plus d. All right, now here's something. I guess I'm going to go over on the side here. X1 over k. K is a fraction. This is something we've had earlier this year. It's one of the reasons I went through it, is we've got a negative half here. And for those of you who remember, when you are dividing by a fraction, you invert and multiply. So I can take x1 and times it by negative 2 over 1, which is simply a negative 2. And so this equation is going to simplify to negative 2 times x1 plus 4, because that's what d is. All right, so that's a little bit of a trick there. That's why I threw this one at you. Not a trick, but something to watch out for. All right, and then our other equation again, a little more simpler. A times y1 plus c. A is 3, so it's going to be 3 times y1. And c is minus 3. A lot of 3's going on there. All right, so now it's just substituting into my values and figuring out what again. Again, I'm going to go with my big number, or my whole number first. So negative 2 times 10 is negative 20. Add 4. It's a minus 16. Yeah, I don't think that's fitting on there. All right, let's try 1. Negative 2 times 1 is negative 2. Add 4. We get a 2. And then 0.1. Negative 2 times 0.1 is negative 0.2. Add 4, you get 3.8. All right, now the y values. Let's see, start at the bottom again here. So put a 1 in there. Well, 3 times 1 is 3. Minus 3, 0. Let's see, put a 0 in for y1. We get a minus 3. And put a negative 1 in there. We get, let's see here, a minus 6. All right. So there's my values. Time to graph this thing. First off, my VA here says it's at 4. There we go. Plotting my points. Let me see here. 3.8. Negative 6. Ooh, right at the bottom here. All right. 2, negative 3. And then I got negative 16, 0. So that's way out here somewhere. Way out here, but at 0. So this thing is going to go just like that. Somewhere out there, it's going to hit my 16. And you can see that this function has been reflected with that negative k value across the y-axis. It's been flipped across it. So there's an example of where that's happening. But again, you got to watch out in case the equations aren't in the proper form. You got to factor out to make sure that they are in the proper form so that you are getting the proper values.